Hi, I'm Leah Zhang-Kennedy. I am an assistant professor at the University of Waterloo Stratford School of Interaction Design and Business. I am presenting this work on behalf of my co-authors on a research about passenger perceptions, information preferences, and usability of crowding visualizations on public displays in transit stations and vehicles. So if you've taken public transit before, you probably noticed that large crowds are common in public transit stations and vehicles, which presents challenges for wayfinding and public health. In our research, we're interested in studying crowd tolerance and preferences for crowding information, particularly how the pandemic has affected people's perceptions towards crowding and the type of information that is suitable in this context, and how the crowding information should be visualized to passengers. In this presentation, I'll be highlighting some of the most interesting parts from a survey and a field study that being conducted with public transit riders. For a complete overview of our research results, please refer to our paper. So we had 3 research questions. The first is, how has the pandemic affected people's perception of risk and crowding public transport? Secondly, what kind of crowding and safety information do people want to see, and when do they want to see this information? Third, what is the preferred visualization design for conveying crowdness information? To address the first 2 research questions, we conducted an online survey with 303 public transit riders in Canada and the US who took public transportation at least once in the last 12 months. We focus on North America because the pandemic began for most people around the same time in March 2020. To address a third research question on the preferred visualization design, we first created 3 crowding information visualization concepts and evaluated them as part of the survey. Next, based on the feedback from the survey, we implemented 2 visualization prototypes and evaluated them on public displays at 3 light rail train stations. So first, let's take a look at the survey. We asked them a simple question about how crowded is it on board for 7 crowd density levels before and during the pandemic. We defined the number of passengers per square meter along with figures to help participants visualize the passenger density. So to provide some context, level 1, which is the least crowded level, is based on Canada's physical distancing guidelines. A Watson signed rank test showed a statistically significant difference in 5 of the 7 crowd density levels between before and during the pandemic. So the results highlighted that during the pandemic, most passengers perceive crowding levels to be crowded or very crowded from 3 passengers per square meter onwards. And some passengers may choose not to board a transit vehicle at all when there's only 2 passengers per square meter on board. What this result suggests is that communicating the crowd density beyond 3 passengers per square meter could be unnecessary because people's boarding decisions are likely to be determined by a lower density threshold. We also, participants also indicated their preferences for 11 types of information relating to crowding, safety, sanitation, and other transit relevant information at 3 points in the passenger journey. What our results suggest that there's a demand for crowding information, and that information about overall onboard crowds and car-by-car distribution of onboard crowds is the most relevant early in the passenger journey when arriving at the transit station or waiting on the platforms. Additionally, we created 3 crowding visualization concepts for public displays using an iterative collaborative process. On the left, our concept we call FULLNESS concept uses a 5-point figurative scale to portray how full a space is in each passenger car. In the center, which we call the distance concept, represents a safe physical distance of at least 2 meters between 2 persons, according to the physical distancing guidelines during the pandemic. Finally, on the right, our occupancy concept is inspired by online seat selection maps to show whether a space is occupied or not. Overall, the FULLNESS concept is ranked high in usability, The distance and occupancy concepts also scored reasonably well. However, qualitative feedback suggested that the distance concept would not scale well beyond the pandemic context, as physical distancing guidelines could change over time. Okay, so let's take a look at our field study where that was conducted at three light rail stations. So our field study was conducted over 5 days with a total of 44 participants recruited at the study sites during June 2020. We set up flat screen displays mounted on a portable stand showcasing our 2 prototypes on the train platforms for a few hours each day during peak hours. We placed recruitment posters near the study area, and passengers indicated their interest to participate by giving us their informed consent. We use a within subject design where the participants view both visualization concept one at a time in randomized order. And afterwards, we conducted a contextual interview after viewing the visualizations. So this is one of the 2 prototypes that we showed to the participant on public displays. So this is the FULLNESS concept. We developed these visual visualizations by processing a subset of sensor data from local transit authority that tracks the number of passengers who get on and off the train at each door at the local train stations. To map the crowding levels in our visualizations, we use the data sets to estimate the total number of passengers on the train and the number of passengers in each car. Next, we animated the visualizations based on the data to simulate real-time crowding information. The visualizations design of the orange and black are meant to match the existing designs of public displays at the stations. For each visualization concept, the participants viewed 3 crowding scenarios showing an uncrowded train, a slightly crowded train, and a very crowded train. So 64% of the participants said that they prefer the occupancy visualization to help them avoid crowded areas, compared to 36% who prefer the fullness visualization. Our qualitative feedback from the participant found both visualization could be useful for making decisions about whether they should wait for the next train due to crowding. However, the occupancy concept is more useful to support passengers' boarding decisions. So overall, our 2 studies found that there is indeed a demand for crowding information, partly due to changes in people's perception of public transit safely since the onset of the pandemic. 86% of our participants said that they have that having access to crowding information makes them feel safer taking public transit, and more than half said that the information will motivate them to take public transit more often. And the second implication is that researching passenger crowding usually involves measurements of crowding based on density, but they rarely consider the role of psychological factors in crowding metrics. What our studies suggest that crowding density communications should be based on passenger perceptions and crowd tolerance, which could change over time. And so these should not be based on the train metrics that define the optimal real passenger capacity. And lastly, despite the convenience of smartphones, public displays and signage are more suitable and a more natural way for people to navigate crowds in transit settings, where people may carry heavy items like luggages, which limits their ability to access their smartphones. Other technical issues such as loss of connectivity may also degrade performance of mobile applications. In conclusion, although commuters will return to public transportation post-pandemic, we suspect that the changes in public perception of transit safety relating to crowding will be everlasting. So transit crowding information empowers hesitant riders to anticipate crowds and allows them to navigate fewer crowds while they take public transits. So thank you very much. We lastly would like to thank the Ontario Centers for Excellence, Rogers Communications, and Helen Displays for funding this research.